First off, welcome everybody. This is a presentation on improved batch management and scalability at C&D Foods, just like it says on the slide. I'm Brian Murphy, and my colleague Liam Deasy, as you may be able to guess, is not with us here today. This presentation is very much thanks to our colleagues at C&D Foods, as the name would suggest, C&D Foods, cat and dog foods, just like the logo. And I'll take you through the company and our own company as well, NeoDyne. We're a systems integrator, and I'll take you through the batch management solution in place and the benefits it brought. And yeah, I'll go through that now. So first up, about our own company, NeoDyne. We're a systems integrator. We're headquartered in Cork, Ireland, as it says. And we're also actually a multidiscipline automation and engineering company. It's not just a systems integration company. We also have divisions or flavors, as I like to describe them, for system integration, power generation and utilities, and for transmission and distribution. I lead the batch management team, and Liam leads the MES team within the company, and that's why we had thought originally that it would be a good idea to bring both to the presentation. We, as a company, are located both nationally and internationally. Strategically located both nationally and internationally is what I have on my notes, which is a very fancy way of saying we have offices in countries around the world and employees in countries around the world. And we're an endorsed AVEVA systems integrator, which we're kind of proud of. The agenda for the presentation, I'll take us through, first off, C&D Foods, and it's quite important to talk about them as a company, because without them this wouldn't have been possible. And then the plant requirements and challenges that they face. I think a lot of people will recognise the type of challenges that they face. It's not just specific to the cat and dog food market, it's very much general food and bev type of requirements. And then what we've got is a plant comparison between a plant with a batch management system and a plant without a batch management system. And then we go through the benefits that the plant with the batch management system has or has achieved in comparison to the one without. And then finally a questions and answer session. So about C&D Foods. They're one of Europe's largest private label pet food companies, and it's a bit of a mouthful but what it actually means is when you go into your local supermarket, whether that's an Albertine here or whether it's a Sainsbury's or whatever it might be, they're the company that makes the own brand product. They make the pet food for the own brand. And that's what private label pet food means. And they've got 8 different manufacturing facilities across 7 different countries. They sell into the US, they sell around Europe. They're a very large company, and they produce lots of different types of animal food, cat and dog food. I personally didn't know a lot about the market until I met them, but if you think about it, it's quite diverse. You've got cans of food, like humans eat. You've got pouches, like when you go to the cinema and you've got your, whatever it might be, Maltesers or whatever it is. There's pet food that comes like that. There's aluminium and plastic trays of food. As it says on the slide, there's lots of different types of pet food, and the company makes 300,000 tons per year. The dry pet food division has 3 different. It's on the slide. I won't just keep reading it. But the most important thing is they're a very forward-thinking company, very proactive, and actually a great customer, great company to work with. And in terms of plant requirements, this is basically buzzword bingo, right? This is everything that everybody wants. It's a list of what everybody wants, but we're going to come around to this again in a couple of minutes' time, and you're going to see how a batch management system manages to hit each of these inherently, not because of what we did, not because of what C&D did, but because this is what batch management systems do. The first thing is full ERP integration, as it says on the top. That means, obviously, ERP down into the plant floor. The next thing, the ability to handle complex recipes, full batch system integration with the SCADA system. I'll speak about that now because I won't probably get back around to it later, but the batch management system from AVEVA can natively integrate into the SCADA system that they have. You've got ActiveX controls which embed natively. You've got .NET controls. So it's a full, I guess it's a good forum to say it's a full AVEVA solution, right? Because that's the presentation that this is. But it is. Yeah. So there's also a paperless, this provides a paperless solution for the plant, and I'll explain why that is the case. It's not just some fantastic, look what we did, we managed a paperless system. It's actually inherently a paperless system. That's the benefit of a batch system. It's got 100% transparency and traceability, and I'll go through that as well in a few seconds, including CIP and SIP, wastewater usage, water usage, everything. And then finally, I suspect a lot of people here have been talking about ISA S95 for the past couple of well, days and certainly for the past couple of hours, but ISA S88 is a comparable standard that interleaves perfectly with S95. It's the batch standard. And although a lot of people aspire to the Purdue model and S95 and everything good that brings, not a lot of people aspire to adhere to ISA S88. So it's important to bring it up. And so onto the challenges that the plants face. And I think that almost every food and beverage plant that I've worked in has comparable challenges. What we did here is we set up a comparison between Plant A and Plant B. And Plant A is heavily automated with full product traceability. As it says on the slide, all the good things it says on the slide, right? Plant B is very manual. You've got people down pushing buttons to start the machine. You've got people choosing from the list in the ERP system what product they should make next. Plant A, it's automatic. I'll go through them in more detail, but the concept here is two plants. Plant A heavily automated with a batch system, Plant B without a batch system. Simple as that. So the benefits the batch system has brought with Plant A: full product traceability. Why and how? The reason for this is the batch system controls the equipment on the floor. The batch system does not record what the equipment on the floor is doing. The batch system controls the equipment on the floor. It's the brain. It decides whether you're going into a heating phase, a cooling phase. It decides whether valves should be opened or shut. It controls the plant. You can imagine why it has a full record, electronic batch record, because it was the one that decided what to do and when to do it. Whereas in Plant B, without a batch system, the operator is saying, I am now going to dose into the skid. Or you may want to go back to your historian or whatever it might be and pull that data manually from the historian and say, oh, valve opened here, we were dosing in there. So because the batch system is controlling the plant, you've got a full electronic batch record. So it's not, okay, I appreciate it's a buzzword as well, but that's not the point of this. The next thing is the equipment history. Because you're controlling the equipment that's in use, you're able to produce a record for every piece of equipment and how it was dirtied, not just when it was dirtied or its clean and dirty status, but also the product that went through it at any point in time. Because the full batch model exists within the batch system, you can trace each piece of equipment that the batch system controls, and you can have a record for each piece of equipment. As it says, exactly like it says on the slide, it allows you very fast, at a button click, traceability of your equipment usage, and also produces a batch record for you. So in Plant B, to do the same thing, they have to go into their historian, they have to pull their ERP system records, they have to pull their historian records, they have to match them up. It's a slow, labour-intensive effort, and right there at the bottom is what you want. You've hundreds of man-hours lost in the Plant B just to produce records. That's all it is. And Plant A, they exist within the system. I mean, it's as simple as that. So the next benefit, reduced ingredient waste. I've got some nice ways to describe the reduced ingredient waste here, but it's a nice way of thinking about it, right? That in general, food and beverage companies that I've seen, they tend to err on the side of the customer. That is to say, they provide more of that high quality ingredient. So for example, one customer that we have produces a breakfast cereal, and in that breakfast cereal they've got little bits of dried fruit, and that's the expensive piece that they create. It costs a lot of money to freeze dry those little bits of fruit in the breakfast cereal, and their operators will always be tempted to add a little more, because you reduce customer complaints, you'll always make quality teams happy. So if the operator errs on the side of giving too much, then the customers will always be happy, quality will always be. Anyway, I've delayed and dwelled on that a little bit too much, but what actually happens then as a result is you lose money as a plant, and I think the buzzword for this is excess giveaway at the moment, right? So because the batch system controls the ingredient addition, you're really controlling the margins of your expensive ingredient addition particularly, and there's no waste of those expensive ingredients. So in the example that I gave a few seconds ago with the cereals, you're not throwing in loads and loads of those expensive ingredients. And so, yeah, you can see straight out why Plant A would do better than Plant B on that metric. It's extremely simple. The operator in Plant B is tweaking the machine to make sure that the customers are happy. In Plant A, you've got fully automated scheduling. In Plant B, you've got manual scheduling. What that means, in Plant A, the schedule comes down from the ERP system and batches run consecutively. The second a batch finishes, the next batch starts, as long as the equipment is clean. The equipment status is controlled by the batch system as well. That's a standard. Again, this is not something that we came up with, this is what's in S88 standard, and this is what batch management allows. So as long as the equipment is available for use and its status is clean, the batch begins, the next batch begins. In plant B, the operator looks around, the equipment is clean, clicks the start button. How long did it take him to look? For me, that was 2 or 3 seconds, but in a real plant, you could be minutes. And so by our reckoning, you've got an increased throughput in plant A of tens of batches probably per week. That's probably a lot of money in some people's eyes. So shorter time to market. And this is where things get really interesting, because there's a lot of things that I didn't know about the cat and dog food market. But one of the things that I didn't know about was that it really mirrors the human food markets. And there's a trend toward more complex recipes. And there's a trend toward faster churning out of recipes to suit the market needs. So I've got a good example. Adri from C&D gave us a great example in the presentation that we did previously, that cats are extremely fussy customers and they can't give you feedback, right? If a cat doesn't want to eat the food, it won't eat the food, and it can't tell you why. And they're an example of an extremely fussy customer, and in many ways much more difficult than a human customer, right? Because you can survey human customers and everything else. But what we're seeing in the pet food market is a trend towards vitamins, minerals, specific dietary needs for animals, things like that. And there's a need for lots more recipes, and the need is coming much quicker. And that's exactly the same as the normal food and bev market. So how a batch system is better than a manual system or a plant without, because the batch system contains the recipe. The recipe is not stored at the PLC level. The recipe will never be stored at the PLC level. It's up in the batch system. For a new recipe to be created, you can copy the existing recipe, effectively paste it, for want of a nice way of putting it, and tweak it for your new batch. Say you want to have a little bit more vitamins or something like that added, you can add in a phase for that. And for that reason, plant A, they don't require lots of automation engineers to come down and reprogram a PLC. They don't need to reprogram something in a SCADA. Typically, it's the process engineers and the chemists up at the batch system level that are creating the new recipes to suit the market and to suit the plant's needs. In plant B, in our scenario, they've got to get people down to the plant floor to reprogram PLCs. And you can think of I've got at the bottom of the slide, the changeover time and the change management that goes with that. Imagine the amount of effort that you have to go to create a new recipe in a plant that can't do that. I presume many people here actually know this challenge, where you're organizing full teams of people just to create a new recipe down in the PLC, or maybe your recipe is stored in the SCADA and it's hard-coded in. In the batch system, the entire concept is you take that control up into the batch layer. The batch system has the recipe. That's the entire concept. So yeah, again, it's a buzzword, right? That you've got a shorter time to market, but it's a fact. And as I say, that's currently a very big issue in the general food and bev market. The time to market is very important. And then the next thing is on plant B, you're very reliant on the operator to actually do the things that you want them to do. Say in my example of we want a dog food with lots of vegetables added. You are reliant on the operator knowing that your new SOP says, well, yeah, we want lots more carrots, but not so many more peas, right? And that's a difficult thing to communicate down to an operator via an SOP. The SOPs look very similar. In the batch system, the recipe is all done at the top layer. You've got your dog food with extra peas or whatever it might be, less peas, whatever the case may be. So, as I say here, the equipment can be idle during the configuration. You've got a lot of change management is the kind of key word there, and lots of increased time in plant B, increased time wastage, I would describe it as, compared to the plant A. So to come back to our nice buzzword slide, right? Full ERP integration. That's on the slide because batch management allows full ERP integration. There's many ways to achieve it, but batch management can integrate directly to an ERP system. The ability to handle more complex recipes, I've already described why that's the case. The reason is the batch management system contains the recipes. The recipes are maintained and modified within the batch system itself. They can be changed very quickly as long as your process engineers have the ability to do so. And I can tell you, I'm not a process engineer and I know how to do it, and that should give you comfort. It is reasonably easy to do. I would say the GUI is extremely intuitive. It's very straightforward. And then full batch integration with SCADA, I already spoke about that. the AVEVA batch management system allows native objects to be embedded within the SCADA. Paperless records. The reason for the paperless records is, as I said a few seconds ago, the system is controlling the plant. We're not creating a paperless record by pulling data back from a historian or anything like that. The reason it's paperless is because the batch system decided what to do and it created the record as it did it. Simple as that. 100% traceability and transparency. The reason is, again, very simple. The batch system controls the plant. It has control of all of the equipment on the plant floor. You have full traceability of your ingredients as they come into the batch system, what the batch system did to the ingredients, when it did it to the ingredients, the targets it needed to hit, and it did hit them because you don't move on from the phase unless it hits them, and so on. So you have a full traceability from the start to the finish, from the input raw ingredients to the output batch at the end. There's full CIP and SIP traceability. You know where I'm going with this. The batch system is controlling the equipment on the floor, so you know when the equipment was cleaned. You know when the equipment received its hot water, its final rinse, its when it got its caustic phase, whatever it might be, right? So the actual equipment is being cleaned by the batch system. The batch system is choosing when to do it. So the batch system gives you full CIP, SIP traceability. Adherence to ISA S88 and S95 standards. Why? Again, because the batch system is based on ISA S88. They didn't code this in a vacuum. They didn't create it in a kind of a world where there wasn't a standard. They specifically created a product which adhered to ISA S88, that being AVEVA batch management. So that's why it adheres to the standard, not by some kind of a large effort by them to coax the product to adhere. It natively adhered to it. That was the whole concept. In terms of I come back in a second because I think this is important to dwell on, funnily enough. Liam is our MES business lead, as I am the batch system business lead. And the original plan today was to have Liam on stage with us to talk about MES systems. And the reason for that is a lot of what I've just described is what a lot of people who are putting in MES systems would hope to achieve. It's a lot of what most plants would have hoped to achieve, right? And there are fundamental differences, and I think Liam was going to describe it as though the batch system is one of the Lego blocks that builds up your Lego kit, right? And the MES being the overall kit at the end is the way he liked to think of it. I might have thought about it the opposite way around, but his entire concept here was that there's a high degree of overlap between what can be achieved by an MES system versus what can be achieved from a batch system. And an MES system, the needs for an MES system really depends on the user requirements. The needs for a batch system really depends on the user requirements. I'm not saying that a batch system should be put into every plant or an MES should be put into every plant. I'm saying that you need to assess the user requirements. And if what I've said a few seconds ago was applicable to your plant, to go back to it, if these are the key things that you need to hit, you notice I don't have some other things that you might be looking for on there. I'm trying to think like rework management isn't on here, for instance, or I can think of a few other things. This is what a batch system will give you. If this is what you're looking for in a plant, then possibly a batch system is the right solution for you. That's the reason why we put it up like this. I'm going to throw the floor open to questions now, but it's important, I've been told that if you're going to ask a question, please use the microphone, otherwise we won't have the question and the people who are watching on the webinar won't know what the question was.
Any questions? Anybody have anything?
Hi, it's Keith Chambers with AVEVA. Just wanted to get your take on the application, the use of batch management in different industries. So, you know, spec chem versus life sciences, maybe versus beverage or food and beverage.
I haven't used it in every industry myself. I've used it in a couple of different industries. Yeah. Food and bev, life sciences, pharma. I think it's a great product, personally. Mm-hmm. And actually, one of my big, I kind of sound like an absolute, I'm not from AVEVA, just before everybody goes there, right? But I think it's a great product, I really do. I don't understand why more people don't appreciate what it does. Mm-hmm. Maybe would be a good way to describe it. It's not, again, I haven't said that this is, everybody needs this. I've said that I think it's a great product, and if the things on that slide were what you need, I think the product could be good for you, you know. But I have seen it in many industries, yeah, not just food and bev. And every time I've seen it used, I don't think anybody has expressed to me regret that they've used it in any way, and that's a pretty powerful thing. The downsides of it are so few. Like for me, the biggest downside is you have to think about it before you do it. You know, you have to. that's the big
Not
downside.
necessarily a downside.
Exactly. Where some people prefer to just code on the fly in their PLC. You know,
Yeah.
some people, some very strong automation engineers might just prefer. Oh, I prefer to do the recipes myself in the PLC. That's not really a downside in the end of the day. You really want that control. And yeah, on that, actually, the other thing that the recipe management gives, imagine the type of control that you're doing in a food and bev plant or any other plant, life sciences plant, around the PLC changes for a recipe change. The amount of documentation that you're going to have to put in, and in the recipe management system, the recipe approvals process is all inherent in the system. You know who created the recipe, when they created it, what they've changed, who's approved it, everything. It's all in the box. It's lovely. Yeah, I think it's applicable to. There are, I'm sure, industries out there that it won't apply to. Right, construction industries would definitely not apply to that.
Yeah,
But
yeah.
for the industries that I've worked in, I found it a great product. Yeah.
Okay. Thank you.
I appreciate the setup in terms of being able to brag about the product.
Any other questions?
Hey, thanks. I was just wondering about whether the batch management system can be used early on in the engineering phase for production time scheduling and things like that. Or is it really only once you...
Production time scheduling.
Yeah, since it's managing the production anyway, I'm assuming that in some way you build up the time schedule there, or does it do that more or less automatically?
I'm going to try and answer your question. I'm not sure if I'm answering it correctly, so definitely correct me if I haven't answered it right. But in the batch system, everything is built up in phases, and each of the phases, you can have time-based parameters in there, or you can have temperature-based parameters. So one of the phases might be to heat a reactor, and the heating phase, you might have it heat to 100 degrees, and I'll put it like this. In the plants I've worked in, most of the people will know the heating phase is going to take 10 minutes for the sake of argument. But you could also put a timer in there, inside in that heating phase, to say that the heating phase will last for 10 minutes. And in fact, many phases will just be time-based. So within the batch system, you can go down through it and say that batch will probably take 2 hours. If that's what you're thinking about, so that you can say, how long will that batch last? Well, it's the sum of the phases. It's that simple. And if I add in another heating phase at the end, it's going to be 10 minutes longer again. And the phases do not need to be time-based. They're target-based. It could be conductivity, rinse to a conductivity, or it could be to go to a temperature, or to go to a level. And then that level, whether you reach that level is dependent on the inflow from the valve. And you might know what the inflow is in general, and you might then be able to work back what the amount of time it is in the recipe. As I've said, in general in the plants, if I'm talking to the operators, they'll know, oh, that phase is going to take another quarter of an hour. And then they'll know, looking at the batch system, they look at the sequential flow chart of the batch system. This is on all the operator screens. They bring it up. And the question that they'll have is, where are we in the batch? Hang on. Tick. Ah, yeah, I see we're at step 4 there. I'll just say step 4 for the sake of argument. We're in that phase. There's another 45 minutes left in that batch. We'll come back to that in a while. That's the kind of, because we'll be looking, typically I'm looking for downtime. That's my thing. I'm looking for time to make a change somewhere else in the plant. I'm saying, are you guys still in production? They'll open up the batch system. Yeah, another little while left in that. So yes, you can definitely make out how long each batch will take directly from the batch system. Yes, it's not difficult to do it, but I'm not sure if that was exactly the question you're asking.
It wasn't, but it was still an interesting answer. Thanks.
Sorry. No, let's try. Let's try. Are you thinking of early in the engineering cycle as you're trying to design your plant?
Exactly. So
it still applies,
okay.
because of that metric. You're building up the phases. You might know that your product, say, to make a particular, let's say cola for the sake of example, right? You're adding water, and you're adding your oils, and you're adding your flavors into this, and you're adding your sugars into this. Each of these addition phases are in the batch system, and they can be either directly sequential or they can run in parallel. And it's the line of shortest line, so to speak. It's the longest line in this case. You know that the longest line down through the system is the amount of time each batch will take. But you also, if you're trying to figure out your development life cycle, it's also how long is it going to take to build up each of these in terms of the programming. Is it at the development life cycle when you're designing the PLC, or at development life cycle deciding how long each batch will take?
It was more about how long each batch will take.
Yeah, from that it is not rocket science.
Yep.
You're going in and you're summing in each of the phases. I could tell you, probably looking at a batch just out of an unknown customer side, I could tell you roughly whether it was a long batch or a short batch by looking at the phases. To give you an example, it's like drawing the batch, so to speak. The batch system is like drawing the batch. So you're going down through the drawing. It's effectively like a process flow diagram. That's what the batch system looks like. So you're going down through the process. That one is a heating for 10 minutes. That one is a cooling for 10 more minutes, and so on. Yeah, I would say at the design stage, you will know how long the batches will take.
Okay, perfect. Yeah, that was exactly the answer that I was looking for.
I'm glad we tried.
Thanks.
So from there, from operating the batch, you also get data. So how does the data flow go to maybe a data historian or a database, and how do you access that data?
Yeah, great question, because I didn't go in there at all. The AVEVA batch system is natively integrated with Microsoft SQL. All of the phases of the batch get directly sent to Microsoft SQL. You've got a fairly extensive SQL database, which is an absolute joy to go through. It genuinely is. You go through it, and if somebody asks me what happened to such and such a batch, I can go in very quickly into Microsoft SQL and query it and get back a full batch record. So you've got all of the batch parameters going to SQL directly. Push-based system from the batch system into SQL. It's store and forwards as well. And there's a redundant batch server possibility as well if you want to, right? So it's pushing the batch-related information, but not the process-related information. Not exactly what level was the tank at 3 p.m. That goes to a historian. Whole separate data flow. Whole different thing. There's still a need for, maybe not a need, but there's still, in my opinion, a full requirement for a historian or a PI-based system above the batch system. They're two totally separate things. The batch record that you get from the batch system is purely based about the batch itself. What phase ran, when it ran, did it run correctly, did it hit its targets, and it gives you very easy pullback. One customer, they were using a historian to find out how many COPs they ran in a year. It was an engineer's job for 2 weeks. He did it every year. Go into the historian, find all the CIPs. You know, they were going by the valves. Valve open, that's the CIP, yada, yada, yada. I went into the database, into the batch system database, and I think I pulled it back for him in something like an hour and a half. I pulled it back every CIP that he had done in the year. I transformed 2-week job that they had been doing every year up to that point. It transformed into literally 2-hour job. And that's just because he wanted a year of data, remember. If he just wanted one batch, I could have just done it in an instant. But I brought back all the batches for him, yeah. And then from that, we found the final rinse phase of each of those batches, and we found the length of the final rinse phase of each of those batches, and then we decided how much water was being used in the final rinse phase of each batch. And from that, we found out, should we refine the final rinse phase a little bit? And then found out the excess water used in the final rinse phase of each batch, and you can see where we're going with this. They cut their water usage from that. That's what the report was for. And that was a year where they were focusing on water, particularly in that plant. So it was a big deal for them, yeah. So engineering hours saved plus the result. And now we've got a report directly from the batch system that tells them about the final rinse phases only. Yeah.
Okay, thank you.
Yeah, it's a really elegant system, I gotta say, yeah.
We'll take one more.
One more. What if I had got 5 questions?
Go for it.
Hey, I was just thinking for the traceability, pure traceability, will you still use the in-batch, I'm an old Wonder Woman, the in-batch database, or would you go for an MES layer or something for traceability?
I know plants where they're using batch systems right now, and they're putting in MES systems. There's still a need for both, I think.
Yeah.
And it really depends on the user requirements. The batch system traceability is fantastic, no question, but it doesn't trace everything. Like, you might not trace, for the sake of argument, downtime. You know, it doesn't have a downtime module.
I'm more thinking about the genealogy of your products.
Yeah.
And also because you often have a packaging line going after this one.
Yes.
And you want to have that full traceability from your bag to your raw material.
Yes,
And
yeah.
for that, in my opinion, it demands an extra database.
Yeah, I think so. And as I say, like I'm working with a customer at the moment who's putting in an MES system, and they have a batch system. They're happy with the batch system. They're in no way unhappy with the batch system, but they want more as well. And just like you say,
That's for the process part, execution part, actually.
Yes, exactly. Yeah.
Second question: did you ever do Plant B?
No, funnily enough, I did not. Yeah, it was a study that we did for them, and we didn't do Plant B. Yeah.
Oh, you have a business potential then.
Yeah.
Thanks for a good presentation.
Thanks very much.
Thank you.